There's one big idea in the first round of Meet 2, and that is sets. By that I mean a collection of stuff. In this case, usually numbers, but not always. Let's say I have a collection of things. My dog, my computer, my job apparently, no, my job.
Didn't know you had a dog, Nathan.
My mama, who is so fat. My wife.
It was perfect.
Yes, my $1 million. And my, you know what, my TV. And my game system. Alright. Let me give you two categories. Things that exist and things that I have at home. There is some overlap. The $1 million, it doesn't exist and it's not in my house. My wife exists and is often at home. Though not currently, right? My dog does not exist, but if I had one, it would be at home. My mama exists, but she is not at my home. Thank God. My job exists, but is not at my home. Well, not during the summer. My TV exists and is at home. It's just not connected to anything. My game system, if it existed, it would be at home. But I don't have a game system, so it's only here. What else? I think that's everything, right? Computer. It exists and it's at home.
Is?
Oh, it's here now, but it will be at home. So there's 4 categories. There's the things that are part of the set of things that exist. Here's things that exist. Mama, job, wife, TV, computer. That's a set of stuff. I could have a different set of stuff, but then sometimes they will discuss specific other things. The union and the intersection of 2 different sets. So what is the union of the things that exist and the things that are at home? Well, the union, that's when you combine the things that exist and the things that are at home. So I'll combine together my mama, my job, my wife, my TV, my computer, my dog, and my game system. Ugh, I drew that badly. That looked more like a profile of a person. Hey, look, it's the person's eye. And then it's the person's mouth over here. Hey, it's happy person. Okay, let me redo that. Okay, here's the set of all things that are in the union. What happens when I join the 2 sets together? I get everything that is in any of them. When they unite, here are the things that are together in that combined set. All the things that exist and all the things that are at home. As opposed to the intersection. So if someone asks you for the intersection of 2 sets, I like to think of it like a pair of streets, okay? Here's a pair of streets. They cross here, this intersection. Here's the intersection. Note that for intersection it's an N and for union it's a U. The intersection is just the stuff that is on, just the area that is part of both streets. The union is what happens when you add one street to the other. When they unite into a single street, anything that is on either of these would be part of the union, but only the things that are part of both are the intersection. So the intersection would just be wife, TV, computer. Okay, intersection union, great. What does this have to do with least common factor and greatest common multiple? That's the next point I'm going to make. Because that's what they are. Let's say I ask for the least common multiple of 18 and 16. Well, 18 is made out of the set 2 times 3 times 3. Let's use something easier. Let's use 8. 8 is made out of the set 2 times 2 times 2. Here's the set of things in 18. Here's what it has in common with 8. They have a single 2 in common, then 8 has 2 more 2's, and 18 has 2 more 3's. So, why do we care about the union or the intersection of the numbers 8 and 18? Well, the part that's just in the middle, the intersection, in math, that's also referred to as the greatest common factor. Why is it useful? Because if I have 8 over 18 as a fraction, the most I can divide them both by is that intersection. I can divide them both by 2. Woohoo, simpler fraction. On the other hand, the union also sometimes called the least common multiple, or it corresponds to the least common multiple. Why do we care about that? Well, if we have a fraction with 18 as the denominator, and we have a different fraction with 8 as the denominator, and we wanted to add them, we would want to come up with the least common multiple and change both denominators to become that. 3 times 3 times 2 times 2 times 2 is 72. 72 is the smallest possible common denominator. To get there, I'd have to multiply this one by 3 times 3, and this one by 2 times 2. And then I would get the least common multiple. So that's how least common multiple, intersection, union, GCF, all that stuff end up in the same set of problems here. Let's take a look at question 1. This is last year's. Compute the greatest common factor of 2929 and 7575. Let's figure out what makes this, let's figure out what makes this, let's figure out everything they have in common, the greatest common factor. Over here, clearly this can be divided by 75. Over here, this can be clearly divided by 29. 75 breaks down further. 25 times 3 is 75 times 101. 29, well, it probably doesn't. I mean, 29 is prime, but let's say you didn't know 29 was prime, you could still realize that it can't be divided by 3 or by 5, so the only thing they have in common is 101. Now, does 101 break down further? Maybe, but it doesn't matter. Because when I draw my two sets, as it were, here I'll have 29, here I'll have 5 times 5 times 3, and here I'll have 101. Now maybe that 101 can be broken down further. Maybe it turns out to be 7 times 13. I made that up. 7 times 13. But even if so, they're both part of the greatest common factor, and when you were asked to calculate the greatest common factor, you just put them back together. And that would be 101, the greatest common factor. So you don't actually have to take them apart further. 101 is the greatest common factor. let's show other examples where there's overlap between sets and greatest common factor and least common multiple. I'm just going to go down the 2015 set here. For many sequences of consecutive positive integers p, q, and r, the sum is divisible by 15 and 24. In other words, p plus q plus r can be divided by 15, and p plus q plus r can be divided by 24. And these are three numbers in a row. And they want the sum of the two least possible values of p. Let me first point out this is basically 3p plus 3, because q is 1 more than p, and r is 2 more than p, because it says consecutive numbers. So 3p plus 3 over 15 can be divided by 15, and 3p plus 3 can also be divided by 24. In other words, p plus 1 must be divisible by 5, p plus 1 must also be divisible by 8. So, what numbers are there that can be divided by both 5 and by 8? 40 is the first one I can think of, and the next one is 80. Notice that that's least common multiple. All right, 5 and 8 have nothing in common. P plus 1 could be 40, p plus 1 could be 80. That means p, the first two numbers p could be, would be 39 and 79. And then it asks you, compute the sum of the least possible. There you go. Read the question again when you're done. Compute the sum of the two least possible values of p. The sum, add them up, 108, nope, oops, 118, I win. All right. Next question. I hope you noticed that that was the greatest common factor of 8 and 5 here. Sorry, the least common multiple of 8 and 5 was 40, and the next one was 80, the multiples of 40. All right. At a party, there are 40 people. Of the 40 people at the party, 22 people are girls, 5 people are left-handed, and 2 people are left-handed girls. How many right-handed boys are there? So how many people outside of both sets are there? Because the total number of people has to be 40. Well, if there are 2 left-handed girls, that means since there are 5 total left-handed people, that means there are 3 left-handed people who are not part of girls. If there are 22 girls and 2 of them are left-handed, then 20 of them are not left-handed. So out of 40 people, we have 20 girls who are right-handed, 2 who are girls who are left-handed, 3 who are left-handed but not girls. So how many people are both not girls and not left-handed outside any of these 3 sections? Take 40, subtract the 25 that are part of one of these at least, and you get 15. 15 right-handed boys. Yep. Sets, Venn diagrams, don't forget that there's 4 sections. The intersection, each separate part that doesn't intersect, and the outside both. Don't forget that the union would involve all 3 of these sections, and be careful not to double count this. This gets double counted often, so you'd be like, oh, there's 5 boys and 5 left-handed people and 22 girls. There are 40 people. That means, leaving out the 27 people, 13, but then you've double counted this twice as people who are not part of the right-handed boys. There's just because 2 girls are also left-handed doesn't mean they get counted twice as not part of the right-handed boys. So avoid double counting, be aware of intersection, union, when the 2 groups unite, and the complement, the group outside, not part of either. And good luck.